Hello, this is Red G. York. This is a presentation on the Pearson correlation coefficient, which, as you can see, is a statistic for examining the relationship between two variables when each is measured at the interval level, or as scores. Scores, not scars, excuse me, scores. This presentation is about the Pearson correlation coefficient, also known by some as the Pearson product moment correlation coefficient, sometimes simply as the correlation coefficient. I'm going to call it the Pearson correlation coefficient in this presentation. This is appropriate when you examine the relationship between two variables, each measured at the interval level. A couple of examples would be age, measured in years, and salary, measured in dollars, or depression scores with self-esteem scores, meaning you want to know if there's a relationship between depression and self-esteem, or numerical grades in school and parental income measured in dollars. These are just some examples of what you might use the Pearson correlation coefficient for. Let's talk about positive and negative relationships. An empirical relationship is a pattern in data that is either positive or negative, or it could be no relationship at all. A positive relationship means the people who are higher on one variable tend to be higher on the other variable. A negative relationship means the people who are higher on one variable are lower on the other variable. Look at these examples and tell me whether you think it would be a positive relationship or negative. Let's look at each of these two situations and hit the pause button and look at it and decide whether in each of these situations you would expect to find a positive relationship or a negative one. Then hit the pause button again and come back to me. Okay, the first one is self-esteem scores and numerical grades in school. Self-esteem scores here are where higher scores mean higher self-esteem. Of course, grades in school, higher numbers mean higher grades. I would expect a positive relationship because those with more self-esteem would probably have better grades. Number two, scores for self-esteem and scores for depression. I would expect a negative relationship here because I think people with higher self-esteem would tend to have lower depression. The values of the correlation coefficient is presented with the letter R, small case, and can range from a low of R equals 0 to a high of R equals 1.0 with or without a negative sign. Most correlation coefficients you'll see will be R equals 0.37, R equals 0.56, etc. You're not likely ever going to see a 0 or a 1.0. Those are just entirely too unusual. You'd expect to find one of those. The negative sign means the relationship was negative, and there is no sign the relationship was found to be positive. Strength of the relationship, the value of the Pearson correlation coefficient will tell you the strength of the relationship. A value of R of 0.86 is much higher than a value of 0.34. So the first would show a much stronger relationship between the two variables, suggesting that one of these variables depends highly upon the other. Let me pose a question to you. What if? Look at these, the statement, hit the pause button, and then come back to me. Okay, here we have a situation where the correlation of income and grades is 0.34. The correlation between years of parental education and elementary school grades is 0.54. By the way, both of these are p less than 0.05, meaning they are statistically significant. So we can take them seriously. So the question is, does income of parental education seem to be more influential on elementary school grades? I would say the correlation of 0.54 is higher. Therefore, parental education seems to be more influential of school grades than does income. If we find the value of R is 0.24, we see a positive relationship. We need to know if we found this value by chance. Statistical significance helps us with chance. If our analysis gives us a p-value that is greater than 0.05, we normally say we have not found statistical significance. So let's look at the question of testing the hypothesis with the Pearson correlation coefficient. To say our data support our hypothesis, we must have data that are one, in the direction of the hypothesis, and two, statistically significant. Failure on either of these requirements means that we say our data fail to support our hypothesis. You have to have both of those present in order to say your data supported your hypothesis. Okay, let's go down the let's suppose trail again. We hypothesize that there is a positive relationship between family income and grades in school. We find the following: R equals 0.43, P equals 0.23. The question is, how do we interpret this data? What does this mean? Did our data support our hypothesis? Well, the answer is no, because while the R value was in the hypothesized direction, the data failed to be statistically significant. I'm going to say that again. The data failed to be statistically significant. I'm having trouble with that word, statistically. Okay. We failed to find statistical significance. So our data did not support the hypothesis. With the prior data, what do we conclude? I'm going to give you a couple of options. Do we conclude our data suggests that higher income leads to higher school grades because we found a positive correlation between these two variables? Think about that for a moment. Is this a proper conclusion for this study that was just illustrated? Let's look at another example or another option. We failed to find a relationship between family income and school grades. What do you think? Well, my answer is B, because the data failed to be statistically significant. If we do not find statistical significance, we cannot take our data seriously. Therefore, we cannot draw conclusions suggesting that we can take our data seriously. Let's look at a couple of types of relationship. The positive relationship. The value of R does not have a negative sign if it's a positive relationship, such as, for example, R equals 0.63. That would be an example of a positive relationship. Negative relationship, the value of R has a negative sign. The illustration here is R equals minus 0.46. The minus sign doesn't show up terribly highly there, but there's a minus sign there at minus 0.46. That would suggest you have found a negative relationship. No relationship, or practically no relationship, the value of R is extremely low, such as 0.07, 0.02, 0.04, 0.5, whatever. Those kinds of values would be very low, suggesting there really is not a relationship between the two variables. Now, there's a possibility, although you will never find it, a perfect positive relationship where the Pearson R would be 1.0. I'm going to illustrate that in a moment. This means that if I am higher than you on one of these variables, I will definitely be higher than you on the other one. There will be no exceptions to this rule. I'll show that to you in just a moment. That's when you have a perfect positive relationship, which you're not going to find. An illustration is given here, what a positive perfect relationship looks like. What we have here on the left are average grade in numbers, 75, 76, 78, etc., all the way up to 90. Over here we have self-esteem scores. The lowest one on this particular data would be a 21, goes 22, 23, up to a score of 32. As you can see here, we have a depiction of people. First person is Jim. Jim had a self-esteem score of 21, and Jim's average school grade was 75. That's what his average was for his courses. Tom had a self-esteem score of 22, and an average grade of 76 here. That's Tom. So Tom was higher than Jim on both grades and self-esteem. As you will see with this pattern, this is always true. Pam is higher than Tom on both. Tam is higher than Pam on both. Jam is higher than Tam on both. And the same pattern holds throughout the entire list of people, suggesting a perfect positive relationship. If you're higher on one than someone, you are higher than them on the other. A negative relationship that is perfect would be a negative 1.0, minus 1.0. If I am higher than you on one variable, I will be lower than you on the other in this situation. Because it is a perfect relationship, there are no exceptions to the rule when you compare any set of two persons. Here is the perfect negative relationship. As you can see, it goes the opposite, like this. Paul is higher than Joe on depression, but is lower. Paul is higher on depression than Joe, but is lower than Joe on depression. Mary is higher than Joe on depression, but is lower. I'm sorry. Mary is higher. Excuse me. Mary is higher on self-esteem, but lower on depression. And that's where the pattern goes all the way through here. In each case, if somebody is higher than somebody else on one of those, they are lower than that person on the other. No relationship. When you have no relationship, the data is all over the place. Here is an example. As you can see, there's no strong pattern there in that particular data. Quiz question 1, hit the pause button and then come back to me after you review it. The answer here is the Pearson is D, 2 variables measured at the interval level. Here's question 2. You'll hit the pause button and then come back. The value of R tells us the strength of the relationship between 2 variables. Does not tell us either of those other things. The strength of the relationship. Chance is determined by the value of P. Here's question 3. Hit the pause button, then come back. We must have C, both of the above. Both of the above must be present. Question 4. Hit the pause button and come back. In this situation, it seems that because the relationship between education and income is higher, R of 0.53, it means that education seems to have a higher influence on income than does age. So the answer is A there. Quiz question 5. Look at it and come back. So can you conclude that you found that those with higher self-esteem have higher incomes? The answer is no. Why? Because the p-value was not statistically significant. You must have both of those present in order to conclude that you found this relationship. I hope this was helpful to you. This concludes the presentation.